introduce myself every month, and you guys hear the same story. So I'll have to change it up tonight. So online, you'll find me as U007D or Curly online. And I'll talk today not about my first computer, because I'm going to bore half the room to death on that. I'll talk about my second computer. And I got this idea on the way here because I realized I was wearing my Amiga shirt. My friend got this for me for my birthday just a few years ago. I was like, thank you, it's awesome. But my first computer was a 64, but my second computer was a Commodore Amiga 1000. And boy, had I died and gone to heaven. Significantly more complicated to program than BASIC and 6502 assembly. It was a Motorola 68000 CPU. I learned assembly language on that particular machine and saw like, wow, that's amazing. My first C programming was on that machine. It was SAS-C or Lattice-C. We had both of them. Lots of floppy disks that you would put in one after the other to install a compiler. And it was fantastic. They were not. They were now 3.5. Yeah, if you took the case off, they were floppy, but they were actually rigid for, unlike the Commodore 64's 5.25, we went down to 3.5 inches, and they were very cool. So yeah, lots of games. The sound that came out of that was amazing, and it just blew you away. So that really, I mean, what the 64 started, the Amiga just locked it in, and from that point on, there was no way I didn't know it at the time, but there's probably no way I was going to do anything else. So that's basically my intro to computing, and I would like to invite some of you to share a story with us as well. If I could get this off. There we go. Anyone? Sure.
Here is a Commodore thing. Commodore was my second, but I. So my I don't know if this is on or not, but okay. My first computer. Oh yeah, my first computer was the TI-99. Unfortunately, I didn't have any floppy disks. I didn't have any disk drive, no hard drive, no drive of any kind. So if it got unplugged, I lost everything I had done. That was it. And the worst part of that was we had one outlet next to our TV. And you could have the TV plugged in and either my computer or the VCR or my brother had an Atari. So I would have to fight to keep that thing on to keep my program. So, but the 128 was way up from that.
I think that's an amazing story because when I got my 64, the same thing happened. My parents had just bought it. They had given me the computer, which was expensive, right? And then I was like, this is amazing, but I can't save anything. I had no tape drive. I had no disk drive. And they thought I was so greedy by asking for more. But I made my first game called Space Balloon, and I left that thing on for 2 weeks playing just that one game. And eventually I had to do something else, and I turned it off, and I lost my first game forever. All right, anyone else would like to share a story? How you got started, what brought you here to this group, what attracts you to Rust? Doesn't have to be anything in particular. Don't be shy. We won't bite.
Go to my dad's office. I was born in what is now Ukraine. Back then it was Soviet Union, and my dad was a software engineer. And software engineering in Soviet Union back then was literally 20 years behind US. So I literally had stacks of punch cards that I played with as a kid, like boxes and boxes. And whenever I talk to my dad, who recently retired, about, oh, I'm having trouble debugging this, he tells me how he would literally take the punch cards and take the boxes of them all the way across town and leave them there and come back a week later. And then so when he would get his results, and I had to use a razor blade to cut out little holes and like use tape to fill them in. So, but I kind of had an interesting journey to software engineering. I took CS 142 at UW with what I think was the worst instructor in the history of humanity, who basically for some reason made me think that this is just not for me. So I graduated actually with an econ degree, and then it was late 90s. I'm like, this internet thing, it's happening. I'm kind of building websites. I'm actually, maybe I'm good at it. So I got an entry-level job in building 27 at Microsoft on Windows 98, Memphis. If anybody, you remember that? I don't know. You probably. Anyway. Oh, yeah, okay. So anyway, and then I realized that, oh wait, I'm actually pretty good at this. So choice was one, to go back to college, get a CS degree. Choice two was to take every single CS class that Microsoft used to offer. Like, I think it was like over there in one of those buildings, they had a conference room. So I basically learned programming and was part of the .NET team. And then I left Microsoft, and I haven't touched Windows in at least 10 years. Anyway,
Great. Thank you.
yeah, bottom line, don't believe college professors.
Yeah, if anybody's trying to tear you down, if it's not what you're feeling in your heart, don't buy it. All right, let's go with one more. Anybody else like to share their story? Don't be shy. It's okay. I should say share a story. Maybe you could share a story about somebody else. The person sitting next to you who doesn't want you to talk about them. Yeah. Anyone? Yeah. Great.
Hi, everybody. My name is Roman. I got really interested in Rust around 4 years ago. My background is functional programming with Haskell and Clojure. And one thing that I really liked about the language was that it was able to achieve some of the stuff that Haskell achieves, but through different means. Meaning, for example, mutability. Haskell is like super strict about how you can mutate stuff. And they pretty much make it really uncomfortable to do mutations. And I always thought, pointers are the worst because there's no way to control mutability, until I saw how Rust did it. And I was rather impressed. And it was super cool how the language allow you to define one previous reference to be completely invalidated by moving something. That for me was like, oh, that's so awesome. And yeah, like I started to get more into it. Sadly, I have not used it in production, but I have done pet projects or so, and I'm always happy to meet people that like languages like this and like to learn. Yeah.
Thank you for sharing that. That's great. We are actually, for those who don't know, the first versions of the Rust compiler were written in Clojure until it was self-hosting until it was a self-hosting language. Was it Clojure? I'm sorry, my bad. OCaml. I'm drawing. I'm on crack. Thank you, Jack. I appreciate that. Keep me honest. It was written in OCaml until it was self-hosting. A lot of the people's favorite features, like result and option, are actually these things called, the word that shall not be named. But yeah, the M word, exactly. And lifted, unapologetically from Haskell and many of the features that we know and love today. So it's pattern matching. There's a lot of features in Rust that come from Haskell. And so yeah, very, very cool stuff. Yeah. All right, so we just covered that. Our upcoming meetings are all third Thursday of the month. So that's our regular pattern. As we get toward the end of the year, or if there's a holiday, right in there, we will tend to move them. But so far we're, pretty consistent. So when the following meetings are coming up. Last month, I put out a call for volunteers. I want to say thank you very much for those folks who stepped forward. Carl stepped forward for volunteering to post the videos after the meetings. Dylan, I don't know where you might be hiding. And B. Dillo, don't know your real name. Hi, thank you. Ben, thanks, Ben. For also volunteering to help out. So there were 3 jobs. Carl's going to post the video, so I'll chat with you, Ben, on whether you want to organize speakers or update the meeting and Discord schedule. I got sick for about 3 weeks right after the last meeting. I got sick twice, like back to back, and between work and everything. So I haven't actually had time to meet with Carl, Dylan, and Ben to officially delegate, but I plan to do that by the end of the week. And then we will get caught up on all the videos that I haven't been posting, and which I have copies of sitting in this computer. and everything else that needs to get done for the group. So that will help us to scale. And that is fantastic because it is just in time for RustConf. The Rust Foundation has reached out to me as a community leader in the Seattle area for Rust. And they have said, they want you. All right, so what's very interesting about what this conference coming up is they are extremely interested. This is the world coming to, this is the biggest Rust conference in the world. It's coming to Seattle, September 2nd to 5th. The eyes of the Rust world will be here, and they want this to be a community led effort. So they're looking for at least 10 to 30 volunteers, ideally from this group, to help with the Rust conference. I have met with them twice now, and I have a follow-up meeting coming up with Beck and some other folks there to talk about exactly what the scope and the roles are and so on. But from what I know, or from what I can gather so far, subject to change, they would like help with volunteers from registration, people to help guide folks to where they need to go, welcoming folks to Seattle, telling them where they need to go, maybe to grab lunch, things like that. Having community-based speakers. There's going to be a series of talks available, not to Rustaceans from Seattle. So if you have a talk that you would like to give, and you two in particular, I think you ought to do this. Not to call, not to single anybody out, but there's going to be some slots available for folks who want to give talks, and they are from this community. So the intent here is to not just have the Rust conference, but also put the Seattle Rust community into the spotlight so that we get lasting benefits from this. People know we exist. We begin to create. There are several conversations I'm having with the foundation on us having co-meetings with other Rust groups from around the world, and we present something here, and we have the AV so that they're attending and vice versa. We can talk and ask questions to one another. So building communities. Some folks, I'm not sure if we have anybody here tonight, but driving up from Oregon, right, to come to this meeting. I've never thought really about what could we do with Oregon Rust community or the California Rust community or the Vancouver Rust community, and they're all right here. So there's a lot of opportunities here that they're talking about and helping us connect with to help enrich what we do. So I'm going to create a channel on our Discord, and if you're interested in volunteering, just pop your name into that channel that I create. I'll just call it RustConf Volunteers, and just pop your name into that channel. That way, I'll have the list of all the people who are volunteering. One of the tasks that I did not write down, I just remembered, was to review some of the talks. So if you feel like you have enough Rust chops to be able to review submissions and make recommendations as to sort of, I think this talk would be really good, and maybe not so much this talk, it'd be really helpful to have folks review submissions for talks. Okay, so great. Yes, any questions? The question is, if you volunteer, will you be able to attend the conference? This is one of the questions I have. I believe that if you volunteer, they would give you free tickets, yes. But please don't, I mean, this is going on the air, so everybody's going to see it, right? It's going to be on YouTube. Everybody's going to see it. But yeah, don't tell anybody. But yeah, don't quote me if after talking with Rebecca and everyone else, if they're like, well, that's not how we do things, then absolutely that's not how they do things. But my understanding is they would give free attendance to all of the volunteers. Fingers crossed. Other questions? Yeah, just happy that you could, yes, just happy, right? Yes, great. Yeah, it's going to be a fun time. Note to Ava, I'm probably going to take that week off work. It's going to be kind of fun. You should too. All right. Yes. they'll be like, there's going to be, I think they were estimating 700 attendees and stuff like that. So it's going to be actually in Seattle proper, and they will probably rent out a chunk of the conference center or something along those lines. Does anybody know what the venue is? The Hyatt? Okay, so they've rented. Hmm?
The Hyatt.
Yeah, okay. So it looks like they've rented a chunk of a hotel downtown. Yeah. And that's usually how they do it. So yeah, it won't be here in Redmond, just in case anybody's wondering about that. All right. Okay, any other questions about that? There will be much more to come on that as I have those conversations. I'll keep you guys up to date, but once I create that channel, please go ahead and, sign up and write your name in there if you are at all interested. Great. Okay, more innovation. We usually meet at Flat Stick Pub, but after our meetup. But we have some members who are not old enough to get into a bar, and we want to be inclusive. And we have racked our brains for like a year to figure out what we could do. Where could we find a pub? Where could we go? And the C++ group, who meets here at the same time as us right now, they're like, well, we just go to Red Robin. And I'm like, how did we not think of that? So I actually went to their après-ski last time, and they go to the Red Robin. I think it's called Overlake Red Robin, right? And they have enough room. They could probably take us both, but we don't want to start any sort of bar fights. So there's a Red Robin at Redmond Town Center where we usually go anyway. So I think we should just crash that place tonight and see if the Red Robin works, so that way we can be inclusive for everyone. Does that work? Everybody's okay with that? Okay, cool. So let's give that a shot. Redmond Town Center, Red Robin. The details are right here in case you want to know the map. The address is 7597 170th Avenue Northeast. Okay, give that a shot. See how it works. Yes, Jack.
I'm happy carpool with people who want to ride and happen to have a car. Yeah, I'm sure several other people are as well. So join us.
Yep, absolutely. In the same boat. Parked right out the window there, and so if anybody needs a lift, just let me know. All right. Yeah, oh, by the way, anybody online, I believe we can hear you if you unmute. So does anybody online have any questions about anything that we have covered so far? The Rust meetup, anything like that? Okay, I don't see anybody unmuting, so I'm going to assume that's a no. As always, we will put these on YouTube. Thank you, Carl, for your help on that going forward. And Dimitri, this is the part where I do make the call for speakers. I have one speaker already signed up for March. I have two people who have reached out to me to do a talk, but I have not yet had a chance to respond in depth and get them into there. So we've got about, I'll say 50-50 chance. So let's say we've got two people for speakers. It sounds like, Dimitri, you have a talk that you'd like to give as well. Okay.
For Rust and project which is a local Redis, so the SDK for Rust. Talking those.
Okay. Great. Yeah.
Specific to Redis, but I also talk non-open source C project. Have complicated piece of C code that you might not want to touch much, but you can build a Rust.
Put a wrapper around it. Exactly.
Or make a Rust extension and make a very few changes to C code and inject some new functionality.
Great. All right. So for those at home who don't have a microphone for that, Dimitri says that he works at Oracle and that he provides, basically he's working with Redis and Rust. So getting Redis and Rust to work together, he can give us a talk on that. So that sounds really interesting. And are you on our Discord? Yeah. Okay. So yeah, join us on our Discord channel and yeah, reach out to. Really? Ah! Okay, thank you. I am trying to stamp out the bad link, and apparently it's still there. If we go to meetup.com, because I spent almost 40 minutes just erasing all the bad links. So if we go to meetup.com and I look at any of these on our Discord server and I copy this link and then I go back to here and I go to edit mode because I got to do it right now. Uh-oh, that better not be the same link as, oh, right, it's, yeah, it's just so hard to get a good link. Okay, so I'm going to do that. I copy this link. If I look at it, that is correct. That is not the W one. All right, so this link, here I am. I don't know how to get, oh, I have to get out of full screen mode. I don't know how to get back to edit. How do I get out of presentation? Open it. Wow, that's complicated. Okay. So the actual link should be this. Thank you for letting me know that. And I will make this correct. So that way also anybody who visits this slide deck will get the updated non-expired link. Wow. Didn't realize that would be so complicated, but thank you. Okay, yes. All right. I think that was everything. Okay, perfect. All right, so tonight's talks, we have writing a library with Sans.io at an intermediate level. And we also have coding with AI help, which is going to be all levels. So I think we can start with Apoorv. We are taking questions. Just remember to repeat the question for the who are.
Probably do the questions end.
Yep.
Since 20 minutes.
And I think well, you've got a little wiggle room. Should be live. Now your screen won't show up on join the. Yeah, it's aka.ms/.
/rug 2.
Yeah, aka.ms. /2.
Sure. /20.
All right, so now you can share your screen. Yeah, okay.
So you want to mute me? You wanna that's
Yep.
yeah,
That looks
join now.
good. Your audio is off. Perfect.
share will give you.
Hello, a lot of people. Can people hear me? Is this working?
Yeah.
Cool. Hey there, I'm Apoorv. I meant to give this talk a while back, but I had to cancel because life stuff was going on. But thank you for having me today. And today I want to talk to you about Sans.io. Basically how to write networking libraries without I/O. And we'll discuss why you might want to do that. Personal intro, I'm currently at Cloudflare doing some protocol stuff, and in the past I've done some maintenance on quick libraries and TLS libraries, so a little bit dabbling of protocols and libraries. And so before we get started, like, what is Sans.io? I didn't actually know what the word sans meant. It comes from like Latin. We never use the word sans, but it essentially means without. And so Sans.io, without IO is what you're trying to do. And the question you might think of is like, is that actually useful? Like, why would, like, if your network library is not doing any networking, what's the point of that? And there's a loophole there, but we'll get to that. And today I hope you guys, y'all walk away with something. And here's the things. So why do we want to avoid IO? Like, why are we even here talking about this thing? What is Sans.io? We'll go into that a little bit. We'll have a little cautionary word about async programming. I know it's like cool, but it's sorry. But I think it's not free. So I think we should realize that and be cautious when we adopt async. And typically you do want async, but I think you should just know what that leads to. And then finally, we'll go into like architecting a library using Sans.io. And this is a short talk, so I'll do some pseudocoding and stuff and try to get some point across, but happy to talk afterwards as well. Okay, so why do we want to avoid IO? But to put the problem in context is a lot of people probably are, this is assuming, but people are familiar with application code. What we're talking about here is networking library code. And so there's a little module inside your application that's actually talking to other, computers over the internet. And so they have to decide on a language, and the protocol is that language. And so different protocols that you might have heard of are IP, TCP, HTTP. These are all protocols that both computers on both sides of the internet decide to talk. And so the networking library essentially is the implementation of that protocol. So you have to be correct, you have to be, fast and secure and all that stuff. And a networking library has many components to it. So when we're talking about IO, we're talking about the component that's sending and receiving packets off that socket or network. And there are other things that it also does that we have to be responsible for. But if you now look at that component, why do we want to avoid it, right? Well, it turns out it's actually really difficult. If you look at like the Linux man pages, the list of errors are very long. And a lot of them just are not under your control. You can have limits, memory process limits. There can be permission issues. You'll just get interrupted. Your application users might be doing something weird. You have very little control over that stuff. And in order to make like a good production networking library, you have to kind of handle them all. And ideally, you sort of have a really nice API so your users don't have visibility into these errors, but it's really tough. So it's really a full-time job in its own to like make a robust IO component to your library. APIs can also be platform dependent. So if you're trying to support multiple platforms, your code now has a bunch of like branches sprinkled into it, which makes it harder to maintain, and it's just more risky. Maybe you don't want that in your business logic of your protocol library. And I'm using the word protocol, networking library sort of interchangeably, so just excuse me if I say that. If you're trying to support really high performance IO, a lot of these technologies have very different architectures, so you might end up just rewriting or having to rewrite your entire like library if you haven't thought about it, which can be tough because you've spent all this time testing and writing this really nice library. And finally, if you do want to have a production networking library, you probably don't want blocking code. And so non-blocking code really kind of means that you're probably doing async. And we'll see how that adds more complexity to your code. And you don't necessarily want that complexity in a code base that you want correct, or it at least makes it a little bit more difficult to make correct assertions. Okay, so Sens.io. This is sort of the slide from before. Is that actually useful? And turns out all we're doing is sort of abstracting out where this IO layer is. So our world is essentially going to be buffers. And turns out buffers is a really good way to model the network, right? You have packets coming in. That's sort of what's happening on the socket. And so your networking library task, and so you can think of these as like Tokyo tasks if you're familiar with that. They're running at the same time concurrently, but your networking library task is simply going to interface with buffers, a RX queue and a TX queue. So it's going to pull packets off of the RX queue and it's going to shove packets onto the TX queue. And then you have a separate task, which is all the complicated IO bits. And that's the thing that's actually talking to the internet, socket IO, or any other weird high-performant IO library that or technology you want to support. And that's where all that complicated logic can live. And so the cool part about this, obviously, is that you can swap out that networking task, right? If you design your library to just interface with buffers, a lot of platforms have support for buffers. And so you can plug and play your different networking tasks as you want. So that's sort of and obviously you might ship your library with some default networking task, but you're not binding any other user from using that. You can swap it out. And the promise of Sens.io, I think the first one really is, in my opinion, the most important thing. It's going to lead to really well-tested code. You don't have to handle all these weird IO cases. That leads to really simple testing, and we'll see an example of that. And if you can guarantee your protocol is correct, your customer is going to want to use it, right? It's going to be reliable. It's going to be less complex, so you will have more contributors. You can actually get a lot of performance. Turns out modeling buffers or IO with buffers is what some of these like higher performance technologies end up doing as well. So it lends itself to like pretty well performance tuning. And it can be, as I said, platform independent, so it'll be portable across platforms. This talk sort of rendered itself from my attempt to write a Raft protocol. I haven't finished it, but there's some code there. And so here's the test that, gist of Raft is it's a consensus protocol, and your server can be in different modes: follower, candidate, leader. And here we have a candidate mode, and we're invoking the candidate to start an election. And when that happens, what it should do is essentially to all its peers, it should send out a request. So you can focus on those lines there. It'll send a request to all its peers to grant it votes. And so if you want to assert that did it actually do that correctly, all you have to do is go to your peers IO, its send queue, and then just pluck off the RPC that was sent. And you can assert that it is in fact the request vote RPC. If you tried modeling this with sockets, we have 3 peers here. You have 3 different like fork processes things. You have like fake Unix domain sockets. Maybe you're having to like pull them asynchronously. On the other end, you're like having to read these RPCs, making sure they're correct, and like bubble back the error. It gets really complicated, probably hundreds of lines of code. That's a lot of that is just boilerplate. So the simplicity of just being able to test something like this is, I think, phenomenal. And there's a lot more about testing that's really cool with this sort of simplistic view. Buzzing becomes really easy when you do it this way. That's a really good benefit of that. Cool. So cautionary word about async. So we'll look at the example of Raft again. So in this example, we'll attempt to receive an RPC. So we'll have a server. It has some sort of mode attached to it. So that's the candidate, follower, leader. And in my implementation, I ended up writing some code like this. So on receive, you hit the server with the on receive function. It boils down to the mode function. It boils down to the follower function. And within the follower, you'll eventually boil it down to receiving a append entries RPC. And so if you look at the append entries RPC, one of the things that it has to do is once it receives it, it has to respond back to the leader saying, hey, I accepted this, or no, I do not accept this because I don't recognize you as a leader anymore. And so what that means is that very last line, you're actually sending. That's IO, right? So now you just, and we discussed how a production networking library should be non-blocking. So you want that to be async, non-blocking code. But in order to do that, what you've essentially done is ended up boiling that async await all the way up your chain. Even though there's a single function call at the very, very bottom, every single other function needs to be async await. I don't know if you've tried using async await in your code base, and when that happens, it's like, okay, I guess like that's my library now. And there's like support for like weird async trait things, and the ecosystem's still evolving. And it just feels like, I don't know, I'm relying on this like third-party async await library. What am I doing with my life? So, and that's fine, but like, what's the cost here, right? The cost is that async await, your program is now running concurrently. You no longer have a linear stack you can just debug easily. When things crash, you have no idea what code ran when, and that makes it much more difficult to debug. There are tools, Tokyo Console, I haven't used it myself, but from what I read, and I have the reference here from an article, so based on that, it's not a perfect tool, so it's also another tool you're learning. So it's just a little bit more complicated to go about debugging your code. There is a lot more machinery now. You'll maybe have to deal with send, sync, pin, and like static lifetimes and stuff. These are not beginner-friendly concepts, and like even if you are advanced, I feel trying to write and reason about these things is just asking for trouble. Writing async await, you'll maybe have to deal with that a little bit more. And finally, you've introduced a new class of errors, right? So your program is now concurrent. You have to start asking questions? Can that block? Maybe will it deadlock? You also haven't tested all the various ways that your code flows. By that, it means like, did one task interleave? Since all your tasks are interleaving with each other, you can't be sure if you've tested every single code path. Again, there are tools. I believe Loom is a tool that will sort of exercise and try to test all these things, but you've introduced a new class of errors, and that's something you now have to test for. And this is, again, I want to frame this. This is in the context of a networking protocol library where you want to be correct and you want to be minimal. In an application code, it might make more sense to be async, and you probably want it to be, but you want to sort of avoid these issues if you can when writing low-level library code, in my opinion. Okay, and let's take a look at how you would go about architecting some Sans.io code. And I have a few examples, and they're pseudocoded, in order to get the point across. But some of the two guidelines we want to sort of approach this problem with is we want to avoid socket APIs, so avoid I/O, and instead use buffers to create that abstraction. we also want to avoid async, and you still want non-blocking code, so you'll end up managing those features yourselves. And so this is the diagram we want to sort of mimic. And the thing you'll end up doing is you'll essentially create your own event loop. Your event loop is the thing will be the interface to the async part of your, I guess, application. So the application is going to call your event loop, and that's going to run your library code in a non-blocking manner. And this is a very simplified version of the event loop, but the most important things that it needs to do is it needs to pull the networking task to do the RX and TX. So it's pulling and transmitting, receiving and transmitting packets off the socket and pushing it onto the queues or taking it off the queues. You'll have some timer components, so it's going to pull that to make sure that if there are any sleeps or wait or timers that need to be sort of invoked. So often in networking libraries, you'll have, if you haven't heard anything for maybe a second, pull your peer to make sure it's alive. Otherwise, you want to maybe kill the connection. So you'll pull that timer yourself and make sure that's progressing. And also you want to give the server, in this case, I call it server, that's your networking library. You want to give it a chance to, process those packets, receive those packets, and make progress. So that's a very simplified view of what your event loop will look like. And then the sort of next example I want to sort of showcase is what does your buffer, your IO buffer interface look like? And there's a lot of code here. I'm going to try to break it down. It's less complicated. Well, it's complicated. There's details missing. The Waker stuff is a little complicated, but the general gist of this is that you're essentially creating two queues, and you're wrapping them in arcmutex because these are concurrent tasks. Remember, these queues have to be shared between your server task and your networking task, so they need to be potentially accessed or need to be accessed concurrently. So you need to wrap that in arcmutex. And you will give one handle to your server, one handle to your network. So the networking code is not really shown here, but it's very similar to the server code. And you're also giving these wakers, and that's sort of, I don't think I go into this, but the idea that there is that if your networking task receives some packets from the socket, it needs to somehow tell Tokyo or / your server task that, hey, you need to wake up and maybe do some work, right? If you don't do that, there's no way for the server to wake up and actually do anything. So the waker is the mechanism to sort of inform the server, hey, we have new packets. You should wake up and attempt to process these packets. That's sort of the linking between these two tasks here. And I don't really go into that, but that can get a little bit funky. Happy to talk about it more later. And so your server IO, so the server IO struct here is going to implement two different traits, a TX and an RX trait. The TX trait is super simple. It's you have some data and you want to essentially push it onto the queue. So self.txq, we lock to get a handle or lock onto that queue, and then you just extend that with the data you have. And then again, you're going to want to tell that waker to wake up so that the networking task in this case knows, hey, there's some packets or some data in the TX queue. I should wake up and try to take that and push it out to the socket. The RX trait is going to have two different functions here. I maybe could have simplified this for the example, but your receive is essentially very similar. You're just looking at that queue, reading some bytes off, and processing that. Not super complicated. And honestly, pull ready is not that complicated. You're just looking at that queue again, seeing if it has any data, and if it does, you're just returning ready. Otherwise, you're returning pending. So the implementation of this is really, really naive and not actually that complicated. You can go about implementing your own buffers, try to make it more performant. There's a lot of optimizations that can be done here. That's kind of it. There were some more examples that I decided not to go into because there's a lot more code. But yeah, I think I'll take some questions now. There's a lot of talking that I've done. Yep. Oh, it's a toy project. No one's using it. No, I've always been curious about like, oh, sorry. The question was like how the project came about and who's using it. No one's using it. It's my toy fun project just for learning. I've always been curious about distributed consensus protocols, and Raft sort of advertises itself as a very simple to understand protocol. Turns out when you try to implement, it's actually very complicated. There's like a lot of edge cases, and I think there's like a sub note, like if you want it to be performant, there's actually a lot more complicated stuff you need to do. So it was just my attempt to learn. Yeah. Yep. Yeah. Yeah, really good question. So the question was there was a lot of in the code examples there was a lot of references to like wakers and contexts, and the question was, have I rolled out my own runtime or was I using Tokyo? And the thing is, in my example I am using Tokyo, but you're not obliged to use Tokyo. The whole point of this is that you can swap out your networking task with whatever you want. You can drive your runtime with anything. So you can take your library, put it in a C library or put it in Java, and you can bring your own runtime with you. All you need is a way to pull that feature and sort of hook into the Rust future, I guess, APIs. So in my example, I am using Tokyo, but you don't have to. Yep. My current team does, but I did not personally work on Quiche. Yeah. 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 It's complicated. So yeah. So I guess it's a you might think that a lot of, I guess, and correct me if I'm wrong here, a lot of networking performance is, or boils down to essentially like managing queues and buffer sizes. And the question was, by introducing these queues within your library, are you introducing additional penalties that are actually going to hit your performance? Did I paraphrase that correctly? So yeah, it's difficult, right? So essentially your socket is a queue, right? It's just something that your kernel manages. So it has, it's probably using some sort of congestion control algorithm. And if you're using just a default one, cubic, the way that operates is just going to send packets until it gets a signal of like lost packets happened. And that happens when you've essentially filled up your queue and nothing more can fit in. So there are other algorithms like BBR that instead of shoving packets and getting lost, they try to sort of infer the size of the queues along your system, along your networking pipe. And so instead of like getting lost, they try to get to like 90% and avoid loss altogether. And so they'll sort of it's kind of magic also. It'll like sort of guesstimate and like avoid loss. And so um, the buffers and queues and sort of loss associated with queues is because you don't have any visibility into like you're hitting middle boxes and routers, and every single one of those has a queues. And the general pattern has been you shove packets until you get lost, and then you back off, and then you try again. And so there are other ways to sort of address that, and BBR is a way, congestion control is a way to address that. Another way to address that, and I don't know if we're out of time soon, but right, so there are patterns on the internet of uh, it's called pacing your packets. So you don't want to shove all your packets in a steady stream. You want to maybe pace them out sort of in a step. I don't know the word for this, but periodic fashion, so that you're not shoving too many packets at the same time. So one example might be you send some packets and your client responds with an ACK, which sort of unlocks your ability to send a whole bunch of more packets. So now you're sending maybe like 30 more packets. But instead of doing that, maybe you should send 10 packets, wait 10 milliseconds, send 10 more packets, wait 10 milliseconds. And so when you are abstracting your IO essentially with queues, these sort of optimizations become really trivial. And so the unlocking of performance really is just queue theory, and working on the abstraction of queue is a lot easier than working on the abstraction of IO or sockets. There are other technologies, and the real performance gains that you get from IO is due to like the non-copy nature of IO. So if you're technologies like AFXDP, essentially, yeah, I've read up on these. You're essentially, you want to avoid the cost of copying from the NIC to your kernel to your user space. That copy cost is where you're paying the penalty of memory and CPU. And so by trying to, these technologies like AFXDP actually basically map memory onto your kernel so that you can avoid having to copy through these multiple hops and just access the packet memory directly. Yeah. Yeah.
Thank you very much.
Yeah.
Okay, so we ordinarily take about a 10-minute break, but we are running a little behind here. So let's do a 5-minute break, and we'll come back for the next talk. Yes, sir. How long do you want it?
I don't have a good time scale for how long it is. Have any guess?
I mean, have you been to a restaurant before? So that's about what I would.
How you be? Good, good.
Whatever time it takes to get down there.
You went to Google, right? I went to Google. I left Google last May or so. And I've been looking for a new job. I'm going to start a new job in about 3 weeks. Oh, okay. Where are you going? I'll be going to Apple. Oh, Apple. Okay, awesome. So I'm going to be working on Apple Intelligence. Okay. Yeah. How about yourself? I think you went to Facebook where I. Yeah. I've been there for 11 years now. Okay. Yeah. Cool. Congrats. Yes. Have you been liking it?
I mean, it also depends on
Quite a bit stressful. Moving fast, a lot of breaking things.
I guess they closed
The breaking things is they removed it long time ago. Yeah. Okay. Yeah. We actually had a chance to actually, Rust is actually pretty popular.
Sounds good, man. Sounds good.
It was officially endorsed as one of the two backend service languages. Oh, cool. One is the C++, one is Rust. The problem is the C++ started first. So all the internal libraries are all written in C++. Sorry, I might be.
Not at all.
Yeah, I need a minute to get my computer set up. Sure, yeah. Go ahead. But Okay. Listen, do we have a HDMI I can plug into, or do we
Sure do.
hook up to my
Yes to both.
So, okay.
In order for you to be able to share your screen, you'll have to be on Teams.
All right.
That's what I'm doing right now, where it says, coding with AI.
Yeah, we can talk right afterwards. But good to see you. Jan and I used to work together on the Microsoft Messenger team in Building 25 right there.
Nice,
Quite some
nice,
time ago now.
nice.
Now, let's see. What to do is. Okay, so that's good. And then get the got in this.
Yes.
2-20.
Mm-hmm. And would you like?
Test. All right, let's get started. Howdy, everybody. My name is Pete. Tonight I'm going to talk about how to code with AI help. This talk is rated for everybody. It's for Rust users of all levels, beginner, intermediate, advanced, for C++ users, for Java users, for JavaScript users, for Haskell users, for Swift users. If you program, this is something I think that you will be able to find as somewhat helpful. In fact, maybe you're already doing this, in which case I promise to try and entertain you as much as possible. We'll see what we can do. If there are any questions, feel free to raise a hand or shout out, or if you're online, just come off mute and say something. I'll go ahead and take questions during the talk. You don't have to hold them for afterwards. Sound good? All right, let's go. Okay, for an overview, there are two kinds of ways I've found to use artificial intelligence and large language models to help me code. The first thing you can do is you can hook up GitHub Copilot, or there's an open source thing called Quoto, which used to be Codium, to your editor, such as Visual Studio Code, Xcode, Emacs, Vim, etc. And this will provide completions as your type. So maybe you've already seen this already if you're a VS Code user and you've got Copilot hooked up. You'll be typing along and it will suggest, hey, is this what you wanted? Sounds good. And the second thing you can do is query-based. You can ask a question about your code. So you can hook up ChatGPT, Gemini, Claude, Llama, there's lots more out there now, to your editor and say, hey, what's wrong with this function? Or write me a function to do X. These are the two basic ways, and we'll talk about as you type and query-based ways to use your large language model. So what are some things you can do with a large language model? How do I do things X? Research tasks. So when I wrote a program, I was writing a new app for the Apple App Store on this phone here, and I hadn't used Swift before. Like, okay, I know exactly how I write this in C++. How do I write it in Swift? So it's like, I want to do this in Swift, and it can tell you how to do it in Swift. Or I want to do this for my Apple AI. It can tell you to do it for that AI. I want to do this using the Z library. It'll tell you how to do this using the Z library. Explain how this code works. So maybe you're working with a lot of legacy code. I worked on the Chrome browser, and there's a lot of very old code in the Chrome browser. And I'm always jumping to other parts of the Chrome browser I'd never seen before. It's like, how does this code even work? I don't understand what it does. You can ask a large language model to help explain how it works. Write me a function to do X. Modify my program to do Y. Hey, there's a bug in my code. Can you find the bug? Can you fix the bug? That fix you told me about didn't actually work. Can you fix your fix? Let's see. Write a comment for this routine. Write some documentation for this routine. Make my code better. With advanced prompting, you can write larger applications. So I know one person, I was originally told that he wrote Minecraft in a month by using a large language model. I was then later corrected, no, it wasn't Minecraft, it was Minesweeper. Big difference. But still writing Minesweeper in a month is not bad. Okay, let's see. Check my code for error conditions. Check my code for robustness. You can ask large language model these things. Write a unit test for this code, and we'll look at several examples. You can pass the output of one LLM to another. So say, okay, Claude, write me a function to do this. Okay, GPT, what do you think of the function Claude wrote? Okay, Llama, what do you think of GPT's corrections? And you can also check your solution to practice coding problems. So for the last 6 or so months, I've been looking for a job. So I would do some practice coding problems every day. I would write a unit test for my practice coding problems. I would turn off GitHub Copilot so I wasn't cheating. And then once I was done, I would say, okay, GPT, now how would you solve this problem? I'd look at theirs, and I'd look at mine, I'd look at theirs, and I'd look at mine. And sometimes mine was cleaner. Sometimes mine was easier to read. Sometimes mine was better commented. But sometimes the large language models was. And sometimes large language models found more efficient ways to do things that I didn't find because I was coding for maintainability, not for efficiency. Multi-step reasoning. So you can make several passes over each function. So these are some of the things that I already talked about. But you can first say, write me a function to do X. Now write me some unit tests. Now check the function for errors. Now suggest effects because unit test Y is not passing. Now can this function be made faster? Can this function be made more readable? So instead of just asking it once to write your code, you can come ask it several times and each time try to improve your code. Stories. So I'm going to tell you several stories about things that I tried back when I first started this. So this is using their auto-completion. So I'm in a file and I type the part in bold. At first I'm in the .h file. This is C code, not Rust code. So I type int square, open paren, and then it says, well, obviously you want int x, semicolon. Yeah, sounds good to me. So then I go to the CPP file and I start typing int square, and it returns the rest, and that function looks pretty good. Okay, not so bad. Then I say, let's write a test. So I start typing, and just about the type I type test and SQU, it completes the rest with a nice test for square, which is actually good. It's correct and it works, and the test passed. So it wrote the test and the code, and they both made a pass. So then I said, great, let's try square root. So I did make a mistake which misled the large language model. I accidentally made the type x because I was just dealing with x. So when I type square root, it completes as int x, return x times x. Something looks a little bit off there. So then I say, okay, let's make me a square root test. And square root test is actually pretty good. And it caught the fact that they had made an error. So with Copilot, many times it just sort of offers to finish my comments, and I generally don't find that useful. Sometimes it gets things exactly right. If you are typing something, you pause to think, what's the best way to do this? It might actually show you the completion that you were thinking about. Sometimes I have a to-do, and I'll put the cursor on the next line after it's to-do and stop and think, how do I want to handle this? And it will actually do the to-do. It's like read my comment, understood what I wanted, and delivered code that actually does the thing that the to-do is supposed to do. It doesn't always do it the right way. It doesn't always do it right, but it does it. And sometimes it's exactly right. So like when I was writing custom stepper class, I said, to do, write custom stepper class. And then it just gave me the custom stepper class that I needed. This is about 3 or 4 months old now, but 25% of new code written at Google may be auto-completed because the auto-completion, the Copilot type, while you type, is just helping enough to write that much code. So GPT is able to suggest how to modify the file I'm currently editing, although it would often lose comments in the suggestions. So in this case, I was using Xcode to write the app for the iPhone, something I'm writing in Swift. And as I'm writing it, it's like, okay, how would I change the code to do X? But it doesn't change the code in line in the buffer in the file that I'm editing. It changes it off to the side and says, here's what you should do. So I can copy and paste things over, but it didn't preserve my comments of the code that it was completing. So I had to cut and paste a little bit more judiciously. How do I do X? It's like, how do I hook up to the network protocol that I'm using? And it will usually give you a good answer. I asked it to find a bug in my code, and it found the bug in my code. And as I already mentioned, sometimes it reads my to-dos and fixes them. So mostly we've been talking about the big large language models, the Claudes, the GPTs, the Geminis, all of those large ones that you get to on the net. But local large language models are also very interesting. Now, I started working on this talk like 6 months ago, and I've totally flip-flopped on my position on local language models just because they've gotten that much better in the last 6 months. This field is moving very fast, and I apologize to anybody watching the video 2 months from now. Everything I say could be out of date. Hopefully not, but it is moving very, very fast. So the first nice thing about local large language models is maybe you work for a large company like a Microsoft or a Google who has rules. We do not allow using large language models here because we don't want our code going out onto the net. Now, Google and Microsoft both have their own large language models, so they can send them internally, but maybe you're working for someplace else a little bit smaller than that. Maybe you're working at Amazon and they don't have a big model. If you have a local model, the data never leaves your office. So if you use a local model to help you code, it's maybe not as smart as the models that are out on the web, but it's a lot safer for your company, and your company will probably allow you to do it. And for now, most of the local models are free. So the ChatGPTs and the Geminis of the world will charge you per token, whereas all you really have to do to get the free models is download them, then you're done, and you run it for as long as you want until you find a better one. And you might be off the net and still need support. So today I had a hard time hooking up to the Microsoft Event Network. I had to get the people in the front to help me out. And I did get them to help me out, so I'll be able to actually show you things that hit the net. But if I hadn't gotten them to help me out, I can show you the things that didn't hit the net. So local LLMs actually work. Now, when I first started trying this, there were 2 main projects. There was llama.cpp and llama.file. So llama.file is really cool. It gets all the code you need and all the data you need, puts it in one really big executable file, which you download to your machine. And it's the same file whether you're running on Windows or Mac or Linux. And you just run the file and it runs your large language model and gives you results, which is awesome unless you're running on Windows, because Windows doesn't allow an executable file to be larger than 4 gigabytes. And a lot of these large language models, even the small ones you put in your computer, are more than 4 gigabytes. When I was using Llama 2, it was very slow. I could type faster than Llama 2 gave me results. The results seemed to work for the few test problems that I threw it, but it wasn't that great. But then Llama 3 came along, and suddenly it's much faster than I can type, correct, and giving even better results. So I think as of about 3 months ago, it became viable to use a large language model on your local laptop to help you code because the results are good enough and fast enough. Let's see, that covers everything there. So as you type LLMs, there are two, as I mentioned earlier. One is GitHub Copilot, and this slide is already out of date as of a couple weeks ago. It says paid, there's now a Copilot free version. So if you're using Visual Studio Code, you can hook up GitHub Copilot and get a certain number of completions for free every month. And then after that, you have to pay if you want to get more than that. I've got a paid subscription because it's how I was doing all the Copilot work on my app. And then Quoto, which was called Codium, is a free open source version. Even though they have servers, you don't have to pay for tokens. It's meant to be free. And there's an upsell to a more premium product if you need the more premium product. As far as querying LLMs, so in Emacs, there's a package plugin called GPTel you can use. You can say, I want this LLM, this query, I want that LLM for that query. I'll show that off in a little bit. In VS Code, you can right-click inside the code, choose Copilot, choose Editor Inline Chat, and then you can ask questions in line, like, what's wrong with this function here? In Xcode, they've got a little add-in called Copilot for Xcode, which can also send queries. And there's just a little black circle in the lower right. I'll try and demonstrate that later. So this is a live talk. I'm going to actually try some live demos. We shall see if the demo gods smile on us or not. As I said, for backends, there's too many lists here and getting to be more all the time. Okay, demo time. Don't take my word for it. Let's try this for real. So the first thing I'm going to run is called Ollama. Now let's see if there's a way to make this shell font bigger so it can be seen better. Command plus, let's try that. Excellent suggestion, thank you. Okay, so Ollama is something that you can run, which is sort of like a clearinghouse for downloading local large language models. So I've installed it on this machine. You can run it from the command line. And let's see. Because the last thing I did was Ollama list. So let's Ollama run Llama 3.3. And now let's ask it a question. Let's ask it to write code to do something in Rust. Give me a quick task we should ask it to write code to do. Write Fibonacci? Okay. And it's taking a minute to come up. Normally comes up faster. Oh, there we go. Okay. Okay, write a program in Rust. TO.
It'll understand.
It often does, but this is a demo, and I want it to work nicely. Yes.
Sacrifice. You could get that as a spell checker the other.
So this is a last year high-end Apple MacBook Pro. In some cases, it does. I don't know that it does in all cases. So there was one time I used, I think it was Ollama, and I brought up the task manager and watched the GPU tasking go right up. But it's sort of like you have to tell your LLM to use CUDA or it doesn't. So sometimes I haven't told the LLMs to use CUDA and they've done everything on the regular CPU instead of using the GPU. Yes, I'd be very impressed if they could do it too. Okay, so I said that it returns answers really fast, more quickly than you could type them. It is not doing that today.
Better than your average beginner. And so you say there's something, could you add this function, and they'll write it and it doesn't work. And then you ask it, oh, that didn't work because of this. And they're like, oh, I'm sorry. How about this? That doesn't work. You're like, that didn't work either. And they say, oh, I'm sorry. And they go back to the first thing that didn't work, and they just go around in circles. So do you have any solutions for that?
So one of the things that I've heard is the more good examples of code there are up on the web, the better it will do with that language.
Yeah.
So one thing we can do is put more code where the GPTs of the world can train on it. However, that's not really a scalable solution. So the best thing I can think of doing is trying several large language models and see which one gives you the best results for what you're trying to do.
Yeah.
Carl.
Two things. And I realized I could get Claude 3.5 beta, which seems much better than ChatGPT 4, which I also use but off on the side. So that was maybe just be better with Rust. The other thing is there was a news item today or yesterday saying that Copilot just released a new completion model that was trained on like 30 languages instead of 3. So even if you're not doing JavaScript, you have a better chance of getting good answers in some cases now.
Yep, that's great.
But
Thanks.
it's really good at JavaScript.
I'll repeat the questions. Yes, thank you for the reminder. So Carl just suggested that if you are trying to get good Rust results, there is a brand new Claude beta model that might give you better results than what you have.
And it's included in the paid.
It's included in the paid Copilot. Yes.
There. It also came around the time when people started to move in, indexable, sort of scrapable forums into more like, communities like Discords and stuff like that aren't scrapable, at least not to the same extent. So most of the Rust problems that you're going to run into on a regular basis are not going to be represented in like Stack Overflow, and that I think has led to them being considerably worse. I don't know how we fix that problem other than just being like a little bit more intentional about, posting things in a public space.
I think it has to do also though with the lack of reasoning in a lot of the older models. The newer ones are starting to develop reasoning, and I think process borrow checker and lifetimes and everything require not just pattern matching, but actual reasoning.
Yes.
Right.
Yeah, models are starting to get better at reasoning. So the GPT-01 model does reasoning better than I've seen it done before, but probably still has a long ways to go. So this is taking about 100 times as long as I expected it to, as it did in my trials at home. As I said about Demo God. So what I'm going to do is I'm going to move on and show a couple of other things happening. So this one here is running locally. I'm going to show you something that is not running locally. So let's see. Let's do Medix. That is a good point. There is a charger in my car, but a charger in my car doesn't help here. Yeah, if you happen to have a charger for this, and if there's a place to plug it in, I'm certainly happy to try that. Oh yeah, here's a place to plug in.
You MagSafe? MagSafe?
Yeah, I'm MagSafe. Probably MagSafe 2.
USB-C as well.
Oh,
Yeah.
I see. Gotcha. Sorry.
I think this should work. Okay, it does say charging, so we're getting power now. Okay. So the buffer I brought up on the top of the screen right now is Emacs, and this is some Rust code from Rustlings. Now, one of the things I found during Rustlings is Rustlings, if you don't know, for those of you who are here beginners, is this great way to learn Rust by example. So there's a whole bunch of little files with a problem in them, and all you have to do is try and fix the problem in that little Rustlings file. And I had GitHub Copilot turned on inside Emacs as I was doing Rustlings, and it would suddenly answer the question for me. Like, this is solving it for me. So I had to remember to turn it off when I was doing Rustlings. Okay, so let's go ahead and invoke GPT. So what we have now is a GPT buffer inside Emacs, and we can choose right here which one of the models we want to choose. So these are all the models that it knows about. I have a paid subscription to GPT, so we will use that one. Yes, Command Plus, let's try that. Is that good? And let's try it here too. And here too. All right, so we'll go ahead and use this model that we were already using. Control G to get rid of that. And now let's ask it to write some code in Rust. Give me a task. What?
I got here. Factorial function.
To,
Let's take a number.
okay, compute like the first 12 or the first 50 factorials. Or factorials of the first 50 integers. Okay, I'll make it 30 or 20. And we're not actually running it, we're just asking it to write code. Okay, so below is a Rust program that computes the factorials of, and of course it doesn't word wrap things for us. But this is Emacs, we can word wrap.
Smarter than I am. Wait, tell it to do the same thing with the big nub instead of. That's good to do.
Okay, do the same thing with a big num instead. Okay, so how does this look for those who speak Rust better than I do?
That's the trick.
Okay, so back to Olama. This is just too slow. I'm going to Control C out and quit. Sure, we can give that a try.
gigabytes and you don't.
Yeah, I can try a smaller one. Let's see, which one do you want to try? Maybe Quencoder? Okay, I will fix that as soon as I get this started. Oh, Quen 2.5 coder. Oh, thank you. And now let's make this a bit bigger so everybody can see. Now while that's there, let's see if I can bring up a fresh window. And here I'm going to show running a llama file. So remember I told you the llama file was one big file that had everything in it?
Sorry, we can't see the screen on the live stream.
Oh. Your screen went to sleep.
Ah, good idea. So let me rejoin. Thank you for letting us know you couldn't see the screen. Okay, can you see it now?
Yes, we can. Thanks.
Great, thank you. Okay, so this model came up a little bit quicker. So once again, write some Rust code to compute the first 50 Fibonacci numbers. And this time we'll leave the spelling mistake in. Okay, this is more like the speed I'm used to seeing. Okay, so next thing I was going to show is a llama file running. So this is a llama file that I have downloaded some time ago. So it's going to run locally, and it's going to launch a server, and you can talk to it on localhost 8080. So what's the question we want to ask it? How about find a cycle in a linked list?
Linked list. Write a linked list in Rust. Ask it to write a linked list in Rust.
Yeah, you're right. That would be a tough one, wouldn't it? Okay, how about implement a hash table?
Yeah, I do know. Oh, it's wait. Oh, you said hash table. Okay.
Yeah, I said hash table. All right, so I will go ahead and dismiss that. So let's see, we showed a llama command line. We showed a llama file command line, or with the localhost. Xcode. So let's bring up Xcode here. And I'll bring up VS Code too. Oh, great, it wants to upgrade. Okay, maybe we'll just show VS Code. Okay, so right click, Copilot, editor inline chat. And this is the LED game that Brad brought us. So what's something we should ask it to do for us? Okay, let's ask it to write some documentation for the code and see what it comes up with.
So I've heard a lot of good things about the now that they introduced integrations with 935, which are generally considered to be like the most acceptable, like proprietary.
Right. So to summarize the comment for the people that are listening and for people on video, Sonnet is really good. It does really good work and was only recently added to Copilot. So if you tried Copilot before and had a problem, try it again and try it using Sonnet. Did that get your comment? All right, so there it is working in Visual Studio Code. I wish there was a way to just say no and you run my old version of Xcode. I'm going to skip the demo because we are short on time. Sorry about that, but I do have it working in Xcode. So we showed VS Code asking a question. Let's try a completion in VS Code. So it thinks that what I want to do is peripherals.pin0.setHigh.OK. Probably not. So it's It's guessing what I'm up to. I don't think it is guessed right in this case, but you can see that it is in fact trying to give us something. I've got other files that are better for this, or better examples for this. Yep. Yeah, generally it has the whole scope of this file, but it doesn't know much about what's happening outside this file. And there's not enough information in this file. I don't know of any way to give it extra files for context yet.
I use Cursor, which is built on Claude, and it actually you can drag files in to give it more context.
Yes, I've seen that. I haven't seen that with Copilot yet, but there may be some way to, like, in your prompt, summarize what's going on. Okay, I showed Emacs using GPTel. I haven't shown Emacs doing Copilot yet. Okay, so here is Emacs using Copilot. So this is once again back in the Rustlings example. So it thinks that I might want to do a print alphabetic of self. I totally didn't want to do that. I totally don't need that, but it is a reasonable thing for it to offer. And the function looks reasonable. And it looks like it's actually read and understood something about the comments, because it is in fact somewhat relevant to what we're trying to do in this particular Rustlings exercise. Okay, I was also going to demonstrate Emacs using Ollama, but we are a little bit short on time, so I'm going to get to the rest of the slides. And if there's more time, I'm happy to do more, but with this. So how do you set this up with your editor? So remember what I said at the beginning about things change fast. So I'm going to give you some instructions for what I know about it today. These could be totally different in a week, could be completely irrelevant in a year. So for Emacs, if there's any other Emacs users out there like me, there's a GPTel package, and the GPTel package allows you to switch between different backends. And I found that very useful, and I got a lot of good work done using it. In Xcode, there's an Xcode for Copilot app. In VS Code, there's a GitHub Copilot extension, which is freely available in the marketplace. And there are probably other editors that support this too. So for instance, Vim and some JetBrains IDEs like IntelliJ, CLine, and support it. Writer has its own support for a different backend that's provided by JetBrains. Sublime supports it. As far as setting up local LLMs, the easiest way to do it is just to install Ollama and ask Ollama for the LLM that you want today. And if it doesn't have it in your machine, it will download it right at the beginning. There's llama.cpp and LlamaFile, which I do not recommend. They were the old ways of getting it run before we had Ollama. Ollama is awesome. There's GPT for all. They call it GPT for all, and it's a nice local model, but it really only has one model, which is GPT. So I'm not sure that that's as local as I was hoping. And there's a lot more if you just search. So for VS Code, this is what the GitHub Copilot extension looks like. And I got out of presentation mode, didn't I? Let's go back to presentation mode. So find the GitHub Copilot chat extension and install it. If you have a paid subscription, you can get unlimited completions per month. With a free subscription, you get a certain number per month. I don't remember how many they are. There's also something called Kodo, as I mentioned before. We're hooking up Visual Studio Code to Ollama. There's another package called Ollama Autocoder, which instead of using GitHub Copilot, you can look up something local, which again might be great if you had proprietary code in your machine you didn't want getting out anywhere, or if you were off the net, or just wanted to use a local LLM for whatever reason. All right, so the question is, with these sort of things, can you train on your own code base? And the short answer is no. Now, you can build your own large language model. So you can start with like Llama 3.3, and then you can do some special training of it with some technology called... no, I wasn't thinking of RAG. RAG is something else. I was thinking of LoRa, which is low rank adaptation, which basically means you're passing a bunch of your own tokens in and training on your own tokens in addition to the model that's already there, but the training doesn't overwrite values in the model, it goes to the side of values in the model. But that's a more involved way of setting it up. If you're using Xcode, well, so maybe you're writing an iOS app, there is a Xcode add-in called Copilot for Xcode, which is free, but it's sort of like a donationware. So I donated and bought the guy coffee because I found it very useful over time. And GitHub Copilot now supports Xcode natively, but it didn't do as many things as this Copilot for Xcode add-in does last time I tried it. The last time I tried it, didn't have a way to do query, it just did completions, but I want to do completions and queries. For setting up Emacs, as I recommended, there's the GPTel package, and this link right here for GPTel has all the instructions. And whatever your editor is, if it's not one of the ones I mentioned above, just do a web search. There's probably something out there. Most editors support this now. So which LLM? So accuracy and cost differ a lot per LLM. This is also changing very fast right now. GPT is generally seen as one of the more expensive alternatives. There are cheaper alternatives. The accuracy is changing week to week. So just keeping up on the news is sort of difficult. There are some mailing lists you can join if you are interested to keep up on the news of LLMs as they happen. I've joined 3 of them myself. Let's see. Some LLMs are trained for coding tasks, and those may be better. So the one I tried before, Quen Coder, was really good at coding. There's one called Code Llama that's good at coding, but old now, so I wouldn't use it anymore. The Claude models have been very good at coding, as you were mentioning earlier. And there's some leaderboards right here that talk about which ones are best and cheapest at this moment. For Ollama, there are hundreds and maybe thousands of models available. If you want a list of models, it's available right here at this link. Question? Right. Generally, the leaderboards have some kind of benchmarks that they will throw against the models, and they will try to evaluate the results of the benchmark. I haven't investigated too much what the benchmarks are. The benchmarks are constantly changing too, and there's talk of like, oh, well, this model was trained with that benchmark in mind. So then you wonder how good are the results. Yep, that's a good way to do it.
But when you start to get into like nitpicky details, it can copy or lives and all. Here's the thing I tried on like this model, and like 2 months later, and you went, oh, better answer. Like increasingly difficult paths, like lifetimes of the two. Like lifetime, try everything about. Yeah, that's your live signal.
So to summarize content for the people on the video, try early and often. Things change a lot. Models do get better. The big models may run better because they have more hardware access than you can get on your laptop and a whole lot more than you can get on your cell phone. Does that accurately capture your comment? Great. Okay, conclusions. The first one you already heard me say twice, the field is changing fast. I started this presentation back in October, and I've had to revise it a number of times since then as I check weekly news to find out, oh, that's no longer true. And you even caught me with one thing where I was calling Copilot still not free but paid. I think using AI to code really is the wave of the future. Our productivity will improve. I don't think it's up yet to twice what our normal productivity would be yet, but it is improving. AI still hallucinate. Don't trust what it gives you. Pretend you are giving a coding task to a junior coder and code review everything they do. I've found it using deprecated APIs from time to time. So sometimes it's like, well, that will work, but they're still not great for proprietary code bases unless you work at a company that owns one and can make sure that your company's code doesn't end up as training data. But local LLMs can help. A Copilot will sometimes save you time typing, but it doesn't save you that much time, but will often save you a lot of time doing research. And that's what I found the large language models most useful for, is all the research I need to do. Copilot is magical when it happens, but doesn't often happen in time to save me typing. prompt engineering still matters to get good results. Whoops. So all the results I showed you tonight were with generic prompts that were baked into the tools, but you can get better answers by doing better prompt engineering. When you're doing better questions, the more context you can give it, the better. If you're writing code, the closer to a spec you can give it for what you want, the better results you will often end up getting. And as I said, the more code that is available for the AI to be trained on, the better. So languages that are not in wide use like Haskell, you may not find a lot of good coding answers on them. Languages that are in very heavy use like C++, Fortran, you'll probably find a lot. Java, JavaScript, you'll probably find a lot. And make several passes with an AI in a different expert role. First, find the bugs. Now clean up the code. Now see if we can make the code any better. And agentic AI is being a thing now, which is basically where you get the AI to output some Python code due to an API you've told it about. You then run the Python code to get the answers you need, feed those answers back into the large language model to make its answer for the user. So that's just a nifty thing that I thought I would mention that doesn't affect programming that much, but it's interesting to know that that's where large language models are going, and that's a way to bring more data and information into the large language model when you're writing your solution. This is a bunch of useful links. These slides will all be shared, and I expect Brad will make them available to everybody. Interesting news I found about coding with AI is 25% of new code at Google is AI generated. Here's the link for that one. This is probably an old article now, 5 easy ways to run a large language model locally. Okay. The next one, Forget GPT, why researchers run small AIs, talks about the case for using large language models locally. And there's an interesting video on LLM agents with Andrew Ng at this link. Any more questions? Yes, in the back. I haven't had that particular problem, but the more information you give it in your prompt, the better. So if you say, use the latest version of library X or use library X version 3.14, if that happens to be the latest, it might work with.
Hit the link to the new manual page. Read this manual page and then give me the answer again. Oh, okay, sorry, I was using.
Yeah, one thing I was able to do with GPT while I was doing my job search is I'd say, write a cover letter for this resume, and I'd paste in my resume. For this opening, I just paste in the link that described the opening. And I was actually able to go read that link, read through the opening, and customize a cover letter for that position from my resume. Any more questions? Yeah, soon it'll be just the AIs talking to the AIs. They'll write the cover letter, they'll read the cover letter.
It's Barney Castle, right?
Yes, that is in fact the Blarney Stone.
I've been watching him like, that's Barney Castle, that's Barney Castle.
I was wondering if that'd be a question. Yes.
Data. Are there any like tools that are kind of LLM? Maybe they are LLMs that can generate models, something like that.
Yep. I would train a model to do that, which is a much longer talk. So we can maybe chat a little bit later. I can give you a few pointers, but I don't have a quick answer.
I mean, not the test. You write the test and the AI would just make the code pass.
I haven't tried that. I've tried it the other way around, where I've written the code. Okay, sorry. Yes, I appreciate the reminder. Repeat the question. So the question was, have I ever experimented with doing test-driven development where I write the test and make the AI write the code? And the answer is no, I've done it the other way around, where I write the code and have the AI write the test. That's a great idea, though, and I'd love to try it.
It would go ask the AI to make the code pass. It would do something, And then my script would run all the tests. If they failed, it would just erase it all, and I'd have to write a new test, and I'd write a smaller test. But I found that the AI does a better job with a smaller task. The smaller the task is, the more likely it's going to pass. It was a very interesting experiment.
So to summarize the comment for those who are listening, Kent Beck had a neat idea about how you could use LLMs to both write the code and run it, and then you could write a little script around it so that you'd write the test, it would write the code. If the test didn't pass, it would erase what it had written and you start over. Is that correct? Okay, we need to leave here very soon because it's time for us to go. I did want to say one thing really quick, is that the C++ users group and the Rust users group are going to get together sometime like June, July or so, and do a language panel where we're going to talk about different languages, and we're looking for volunteers to present languages. So we already got one for the language D, C++, Rust, and Swift. But if you know Carbon, CPP, Go, C#, Mojo, Hilo, Circle, and want to talk about the language, please give me a shout.